Well, good afternoon. Thank you very much for your time. I'll try and make it worthwhile. So I work for DRA, a global international engineering and project delivery company, and today I'm going to talk to you about how engineers can help drive efficiencies in mineral processing plant execution. Engineers, I believe, are pivotal in helping clients reach the full potential of their projects. Expediting projects is about knowing when to put the time in and effort, when to expedite and when to take it slow. It's important to understand that what is an engineer's gift to give and how to leverage that to best effect. So today I'd like to take us through the global project landscape briefly, the project life cycle, talk about what is in engineers' control, how we can influence speed and delivery. I'll take you through a couple of case studies and then some closing remarks. So I think today more than ever we're aware that there are a few geopolitical headwinds and changing landscape, hopefully for the better. The global landscape for minerals demand is ever-changing and increasing. COVID has disrupted the supply chains. Clean energy targets are changing demand profiles. Countries look to de-risk supply chains and gain the competitive advantage in a changing market by way of funding, tariffs, export bans, and so on. These geopolitical headwinds make getting a project from inception to profitable production increasingly challenging. Australia is a lucky country in many respects when it comes to mineral abundance and geopolitical stability. We're the world's largest mineral exporter. Mining in Australia employs more than 326,000 people. Remoteness, skill shortages, high labour costs and regulatory congestion make for a challenging landscape to attract investment which has many compelling alternates. Mining is a price taker, and projects must continue to unlock value through the project life cycle. And I'll hopefully convey to you that engineers are pivotal in de-risking future perspectives projects. It's interesting to see the transition or the development of the news articles as we move down the right there. Just today, adding a new one partnership between the US and Australia funding critical minerals. So there are a number of things that an engineer's can and cannot. I beg your pardon. I think I've skipped over a slide. There we go. So I wanted to share this slide just to set the landscape. So there are various ways of depicting the various phases of project development, but the key thing to take away from either of these graphs is that on one axis we have the project value, and as we move to the right, our confidence in those projects increases. Engineers typically get involved in the early stages of our project development, and as such you can see at the highest risk phase of project delivery. Therefore, this is the time to spend the time and money to properly understand your resource, to reduce the risks at the back end. I want to spend some time today looking at what engineers can influence. When considering the feasibility of a new mining project, we often think about the things that we can't change. It can be overwhelming to imagine the technical, economic, social and environmental context that the project may have to endure. How do we navigate through global uncertainty? How do we thrive in the face of disruptions? Today I would like to focus on those elements that can be influenced by engineers, the choices we make, the flexibility that exists in our projects, which will allow us to adapt to the changing environment. But let's just keep it simple. So, some things I'll touch on: process flow sheet and the importance of getting that right. Plant design. I've been told to pause now for 5 minutes, is it? A couple of minutes? I think there's a announcement. I think we're good to go. Plant design and constructability, contracting strategies, and responsiveness to change. Of course, there are some things that we can't influence, your local and social political factors, marketing conditions, geotechnical location. These are obviously things that are outside of our control, I'm afraid. So, engineers are engaged at the study phase or earlier. This is where your project value is built. It's a phase of high uncertainty. Therefore, it is a time to be rigorous in order to remove the costs and schedule risks at the later phases of the project. Some key lessons that we've learned. Do not underestimate what is in the ground. Test work can be more complex and takes longer than what you think. Ore mineralogy and variability of ores are often underestimated. Ore hardness and liberation characteristics that are misunderstood can have huge technical implications, and they will consequently impact on your CapEx, your OpEx, your mine plan, the additional engineering effort to write it, and the project cost and schedule as a result. Make sure you understand the basis of what you want, the offtake, your project size, your product quality. Do not rush the pre-feasibility study. Pay attention to the sample selection for flowsheet development. Here we can see two flow sheets for a gold processing plant actually. Test work plays a vital role during the study phases of the project. The objective of test work is to get the flow sheet right. It determines everything, namely products and markets, but particularly related to volatile minerals and critical minerals where supply and demand relationships have yet to be fully established. Mineral recoveries that you can expect are impacted. It feeds into the CapEx and the OpEx, and it affects your mine plan. Even gold is not a copy-paste these days, with the low-hanging fruit now somewhat long gone. So we can see on the left how different these two are, with on the left float, regrind, CIL. On the right we have single jaw crusher, pebble crusher, SAG mill and CIL. Again, both processing gold. Now I'd like to briefly discuss the contracting strategy and its influence on collaboration. EPC contracts allow for single point accountability, risk transfer, and can be a good option where the commodity process is a well-worn path. Perhaps think gold or greenfields. Drivers include the need for schedule and cost certainty. Do not make a mistake of using an EPC model to transfer poorly quantified risk. Some owners are moving away from this model due to resulting disputes and cost blowouts. Current market volatility is likely a large contributing factor to this trend. EPCM and integrated owners teams are more suited to projects with greater degree of variability and novelty. Rare earths may fall into this category, where risks are greater or harder to quantify. Integrated owners teams where pain share, gain share models are applied are increasing in favour, and they can improve speed of information transfer, offering efficiencies, improving transparency and minimising the risk of costly disputes. The contracting strategy then will set the tone of the project and the way in which people behave. Successful projects are built around trust, and this can make or break a project. So I guess, given what I've just said, we now have a robust DFS, don't we? We need to build this properly. Do not be tempted to re-engineer at a later phase of the project, or cost blowouts will follow, and no contracting strategy will save you. Read the contract. Both the owner and the engineer pore over the terms, and when it is all agreed, the people responsible for actually delivering don't read the contract to understand what their respective obligations are. Write a detailed scope of work and ensure it is aligned with the project execution plan, the schedule and the budget. Make a decision today. Don't be afraid to change a decision down the track if it goes from okay to unsuitable. But resist the temptation to change from an okay decision to a solution perceived to be optimal. Define the key milestones and communicate them to the team regularly. And as an aside, understand your milestones with your engineer and what it is that can't be changed or shouldn't be changed after each of those milestones. Often we see this is not adhered to, and it increases the engineering work, time, cost, schedule and delays. Don't be a bottleneck. You must feed your engineer in order for them to do their job. Make sure you have the right capability and capacity on your side so that you can keep that machine running. Now we get to the good bit. We're allowed to build something. Engineers love plant design. Engineering houses with a depth of engineering experience leverage design replication to good effect, saving project schedule. Modularisation reduces site effort, a benefit in a tight labour market, such as Australia, and reduces install time. There are drawbacks. It pushes up steel use, and a good example of this can be seen to the right. Just a simple stairwell that's been modularised, but of course it has an additional set of columns as part of the modularisation process. If you do modularise, it's worth considering the procurement contracting approach. There is little point modularising pipework and steel structure if the two are not geographically located. Integrating shop detailing into engineering models reduces a set of deliverables to the shop detailer. This is a strategy for compressing schedule. Again, it ties back to your procurement strategy. Assume vendor data is a process that can significantly compress schedules. It does create back-end risk and potential rework, but is typically outweighed by the benefits. A robust process is required to ensure drawing updates are closed out. For example, assume vendor data stamps. Constructability must be incorporated. Considered engineering will ensure lifts have appropriate access. Modules are easily slung and consider the lifting options and locations. And I do have a maintenance and operability background, so spare a thought for those poor guys at the other end of your project. I appreciate that won't necessarily expedite it now, but access and maintainability strategies are easily incorporated into the design phase and will pay their dividends at the back end of your project when you're in operations. So let's discuss communication. Given I'm an engineer, the irony is not lost on me. Communication could be its own presentation, and suffice to say, successful projects have excellent communication. Their communication is decisive, it's concise, and the decisions are documented. Communications by the coffee machine, they occur in structured meetings, unstructured meetings, and through formal tools such as technical queries. I wouldn't mind picking on TQs for a moment, or technical queries. People that have experienced them understand that an engineer typically writes a TQ, takes a couple of days, it goes out to the client. Client insists on 5 days turnaround, 5 days go past, it comes back. Sometimes it comes back with, have you considered? So then the process starts again. TQs are a necessary evil. Clear direction and history on a project is required. Some tips for efficient information transfer in TQs are agree the time limits. That'll keep the engineering team moving if those time limits are exceeded. When reviewing TQs, be concise in your response. We don't ask engineers, have you thought about? TQ's capacity and capability of resources on the client side is critical. This needs to be considered when building your team. Integrated owners teams can supplement this and cut down on the number of TQs that a project will see, which can be in the thousands. Engineers can be a bit like ChatGPT, except less polite. Give us a good prompt and you'll hopefully get what you want. In the context of saving time on projects, effective change management is pivotal to success. Often fast-track projects get going with, at best, vague scopes. Typically, this results in change later in the project, driving rework and considerable cost and schedule delays. It's something I'm sure none of us have experienced. Where we can, change should be minimised. It's important that we define hurdle criteria for change. Engineering companies will frame this for their review milestones, and it's important to bring teams up to speed with that at kickoff. Drawing reviews typically follow a workflow. The time to make changes is at Rev B, not Rev 0, and not issue for construction, preferably. Teams should leverage more frequent design reviews to drive early identification of potential change. It also dramatically reduces those evil TQs we talked about, which can only surely compress your timeline. Fast projects minimise change to that which is necessary for the project's success. The objective may be a suboptimal recovery scenario. Avoid using change to unravel this. Be disciplined. Sometimes the best answer is no. Now, if I can briefly share with you two case studies, and the first one is Mount Keith deep bottlenecking project. That was for BHP Nickel West, where we designed the crushing and grinding circuit. We had challenges of time pressure, and so some of those examples that I used before, we implemented. The steelwork was modularised. Unfortunately, the pipework was too, and procured somewhere else. So that was a missed opportunity. Scope detail, shop detail model integration was incorporated, and we used assumed and procured vendor data. That resulted in us in hitting FID with 90% design maturity. And we just had some AFC holds with the vendor data to be removed. That was a 30% reduction in schedule, and it was the fastest project at the time for BHP. And we got lots of compliments from them for it. A little further ashore, this time in Ghana, at the Asanko Gold Project. Again, this was a 3 million tonne per annum conventional carbonate leaching process plant, including non-process infrastructure, the 80 hectares of tailings dam and 30 kilometres overland power line and substation. Some of the challenges on the project were extreme rainfall and complicated travel arrangements. But I'd like to draw your attention to the success factors, which we believe was a rigorous flow sheet and time invested up front, and an integrated team that resulted in a basis of trust which accelerated all elements of the project. So if I may, in closing, I hope I've conveyed that engineers are integral to the success of our projects. We de-risk projects to bring cost and schedule certainty, and are able to further compress time when trust has been built. So I suggest a few things. Solve one problem at a time and keep 100 others away. Projects that actively manage the decision making, good, bad or sideways, are successful. The time impact on waiting will far outweigh the impact of the odd decision that proves to be flawed. Cultivate a sense of urgency and resource with the right capability and capacity. Engineering determines the value of a project, so do it quickly and well at the start, and have the courage to do more engineering to change outcomes underway that save money and time overall. Projects built on insufficient engineering in the hope of saving time and money statistically achieve neither. Lastly, no plan survives first contact, but with robust planning, you will reduce the emotional scars, or at least some of them. Thank you for your time. I'm Mike Barrenger, I'm VP Project for Delivery DRA. DRA are heavily involved across gold, rare earths, lithium, coal and so forth, both here in Australia and globally. And we'll be pleased to assist you in your project requirements. Thank you.